Still working on the fundamental theorem of calculus. And look what it says. It says, recall. That means we already know this, right? So that fundamental theorem of calculus that we can use to evaluate a definite integral. So if we have an integral from a to b of anything, f prime of x dx, it's equal to f of b minus f of a, okay, whatever the integral is of that. So we use that, okay, that's one way you can always set it up to make sure you add and subtract correctly, but make sure you're paying attention to what the question is asking, because it says, however, we can rearrange. So notice if I took this and I just add f of a to both sides, that I end up with this. Would you agree with that? And when you integrate, this is your initial value, this is your final value, right? So now what this says is this is your final value. It's equal to the initial value plus all of your accumulated change. That's what's happening here. That's what this means. Final value equals initial value plus net change, right? So if I wanted the initial value, I could take the final value and subtract the change. That's going to give me my initial value, right? So that's why you want to be able to think about it in words as well if you need to rearrange things, okay? So a few quick examples, and these are the ones where you got to pay attention, like where you're starting and where you're finishing. So if I have, they give me f of 3, right? I have what f prime is equal, and I want to find f of 7. So f of 7 is equal to, I know I'm going to use f of 3, right? And I'm going to have to integrate this f prime of x dx. Well, my limits of integration are going to be 3 to 7. So 3 goes down here, 7 goes up here. So what I'm looking for is the final is equal to the initial plus that integral. Does that make sense to you? So we can actually find that because that f of 7 then is going to be equal to f of 3, which is 5, plus the integral from 3 to 7 of x squared minus 2 dx. And then, even though this is something we can do by hand, we'll do this on the calculator. And so it's a simple one, but we're going to put it into our graph anyway. So let's go back to our graph, because we're going to practice with some simple ones here. I'm at F2. I want to go back up to F1, right? So I'm going to do tab, and then I can go, actually I didn't need to do tab that time because I was already there. But I'm going to go up to this, right? And I'm here. I'm going to delete all that out. And we're just going to type in, what was it, x squared plus x squared minus 2. So in F1, we're going to put x squared minus 2. Okay, everybody with me? Enter. It's a crazy graph, right? Oh my God, it's a parabola. So now we're going to go back to here. And we're going to type this in, 5 plus the integral. All right, so I'm going to do, oh, okay, hang on. So y'all should have plenty of time, so let's type find in. I'm going to do calculus. I want to do the numeric integral. I'm going from 3 to 7. Now remember, there's 2 different ways to get this F1. One of the ways is just to hit the variable, and then you can choose that F1 of x, and then dx, right? What do we get? 102.333. Okay, so f of 7 equals 102.333. Probably. That's a good question. I don't see why not, but they do say to the nearest 3 decimal places, the nearest thousandth. I would just put the 3 decimal places. That's good, but I don't know the real answer to that, sorry. All right, so now I want f of 1. So again, we know we're going to use f of 3. And I'm going to integrate. My limits of integration go from 1 to 3 of f prime of x dx. So here, I don't want the final value. I want the initial value. So the initial value is going to be the final value minus the accumulated change, which means this is really just 5 minus the integral from 1 to 3 of f prime of x dx, or the x squared minus 2, but we already have that in there. So now we can go back over here, and I'm going to do 5 minus menu. I want to do calculus. I'm going to do an integral. I'm going from 1 to 3 of f1 of x dx. I got 0.33333. Is that what y'all got? So f of 1 is 0.333. All right, how are we doing? We good? All right, so let's look at example 2. A pizza is taken out of a hot oven and the temperature of the pizza is 180 degrees Fahrenheit. The temperature of the pizza, P of T, is changing at a rate of blah, blah, blah. What is the temperature of the pizza after 5 minutes? Now, these questions can be asked a few different ways. We can be asked for the actual temperature, which is what they're asking me for. We could be asked for what was the change in the temperature, but what we want is the actual temperature. That means I want the temperature, which is P of 5. That's going to be equal to the initial amount. What's the initial amount? 185. And then plus, it's the initial plus the change. Now the change will be negative, but it takes care of itself. Does that make sense? Okay. And I'm going to integrate it. What are my limits of integration here? 0 to 5. Yeah, because this is my time. 0 to 5 of P prime of T dt, right? What is P prime? It's given right here, right? Because it says that's the rate at which it's changing. So that's what we'll actually type in. But you don't have to write that down. Like, you want to be careful rewriting that stuff, because if you accidentally rewrite it wrong, then they count things wrong. So then we can just put this right into the calculator. Okay. And so if this is a single part of a question, most of the time they're not going to be singular questions like that. So I think maybe it is safer to always go back over here and put it in to this. I think that's just good practice, good way for you to do things. So that is a negative 0.32 times e to the 1.1x, right? Y'all are staring at me. Why aren't you typing in your calculator? Y'all are the ones that need practice. You're slow. I'm not talking about your intelligence. I'm talking about your button-pushing abilities. It's not a show up here. Putting on a performance. 3 decimal places, yes. Unless you're told otherwise, it's always 3 decimal places. So we get 185 plus menu. I want to do calculus. I'm going to do an integral. Going from 0. Do we understand why it's from 0 to 5? Yes. Okay, good. Of the variable, which is f1 of x dx. And that's what I got. It's more just an application of the stuff we've been doing. So it's kind of a review, I guess. You know what I mean? We're kind of putting things together. Yeah. It's just putting it all together, I guess, which makes it seem like a review. So 114.108. So 114.108 degrees Fahrenheit. Very good. We okay? How are we doing over here? Getting it? Did you actually push all the buttons? That's bad, bad, real bad. What happened? Oh, you put the whole thing in there. All you want in there is the little equation. All you put in F1 is this. So basically, your answer is F1. This is why we're practicing pushing buttons. That's all you put in there. You just put the equation itself in there. Okay. So, but because you put the whole thing, you haven't deleted it yet, have you? Okay. Go back and put the X. And then hit enter. Okay. Now go back to your other page. And so now just put F1. Here, do it this way. F. There you go. And now X. And hit enter. Oh, it didn't like it. Oh, it's because you didn't put a 5 in there. Okay. Never mind. I thought maybe it would just give it to you. Oh, but just put F1 of 5. That's not going to work either. Never mind. Just put that part in there. I was thinking it would work, but it didn't. It did work when you put the 5 in there. All right. Are we good? The rest of you button pushers, we're all good? All right. So a particle is moving along the x-axis with a velocity of this. If x of 5, okay, so look, we got to make sure we understand this too. This is velocity. When it says x of 5, what does that represent? Position. This is the position. How is velocity related to position? It's its derivative. Okay, so a particle is moving along the x-axis and has a velocity of this. If x of 5 equals 2, find the position of the particle when t equals 8. What is the position of the particle when t equals 0? So there's two parts here. So if I want the position when t equals 8, that means I want x of 8, right? I know x of 5, right? I'm going to take the integral of velocity from 5 to 8. So that means, and so I like to write it down and then decide if I'm adding or subtracting, because then this means I want the final that's equal to the initial plus the change, right? So there's a plus here. And then this, I can just write v of t dt. So in my calculator, instead of x of 5 right here, this is going to be a 2, right? So this will be 2 plus, and then I can type in the rest. But in the X or in the F1, this is what I'm putting in F1. That right there. Okay. So I'm going back to my F1. Okay. And I'm going to put negative 1.5 cosine. I want trig. I want the cosine of, remember you have to use x squared minus 3x. You heard what I said. Oh, and that's what it looks like. Okay. It's an interesting trig graph, right? All right, so I'm going back over here. I wish I really, one thing I don't know, I do not know how to clear this screen off, and it frustrates me. And I'm sorry I can't tell y'all how to do it, because it didn't need to be cleared off. It would just make me feel better, and I don't know what to do. All right, so I'm going to type in then 2 plus, right? No, that's an answer. That's not what I wanted. 2 plus, I want to do menu. I want to do calculus. I'm going to take an integral. I'm going from 5 to 8 of f1 of x dx. 1.804. Yay. So x of 8 is equal to 1.804, and we don't have any units. That's just it. Okay. All right, so then I also want x of 0, right? I'm still using x. Still using x of 5, right? I want to take the integral from 0 to 5. Is this going to be plus or minus? Minus v of t dt. And remember, what I'm typing in right here is a 2. What are we doing? Okay, what do we do wrong? You have an F3. Why you?
Because I just kept on going down.
Oh, okay. Which there's nothing wrong with that, but. Your graph looks right. I'm not dividing by 2. I was saying that I'm putting a 2 in for that. No dividing by 2. Sorry. Okay. So 2.093. Y'all good with this over there? Did you get it figured out?
No, I did everything.
But then did it work?
No.
Why not?
I have no idea if I moved on to the next one or
Started the next one. Okay, we'll see. All right. So let's look at number 4. A delicious turducken. It's a turkey stuffed with a duck, stuffed with a chicken. All right, comes out of the oven at a toasty 182. The temperature of the turducken is changing at this rate, degrees Fahrenheit per minute. Find the temperature. Yeah, well, that's why you can't focus on that. You have to, okay, this thing came out of the oven. It doesn't even matter what it is. Find the temperature of the turducken after 6 minutes. So we are looking for the temperature at 6 minutes, right? That's equal to the initial temperature, which is 182. And then I'm going to add to it the net change, which means I'm going from 0 to 6 minutes of, I can do little t, I can do capital T prime of t dt. It doesn't even matter, okay? So type that in. Remember, we're going back over here. I would go over here. I would go up here and clear that out. And type in the negative 21. Oh, that's not a negative. Negative 21.6. Times 0.82 to the x power, right? And then that's what your little graph should look like. Not that we really need the graph. I'm going to go back. I'm going to do 182 plus menu. I want to do calculus. I'm going to do an integral. Doesn't matter. Don't even confuse yourself with them. $106.245. How are we doing? You're not even pushing buttons. It doesn't help if you don't know what buttons to push. What the heck are you doing, man?
I have no idea. Let's go to...
Okay, so go back to your graph. Something's not right there. Oh,
I'll explain it.
Yeah, you got to put in the whole thing, dude.
Oh, it's because I put times.
Saying my mama can type in these calculators faster. Good job. Oh, not good job. What the heck did you do now? Okay, go back to your graph. You didn't change it. You didn't hit enter. Y'all are killing me. Okay, I'm going to write this answer down. You're going to have to go back and figure out how to get it. No, I'm letting you type. 106.245 degrees Fahrenheit.
This is not the graph. What did I do wrong?
Oh my gosh. Because you have it times x, it's to the x power. You put it in parentheses. You put it literally exactly like it looks with the parentheses and everything. Just type in what's there. Okay. So write down the answer, and I want you to come back and push the buttons because I do want you to do it, but I want to set up, we need to set up some of the other ones. Okay. Oh, wait. Well, is that wrong? I got 245. Oh, 246 is fine too. Yeah, I'm sorry. 6. Both of them are okay. All right, a small baby pool. Let's move on to this because I want to set them up, and then y'all can go back and I'll help you with the calculators. A small baby pool has 75 gallons of water in it. However, since it was a cheap pool bought from Walmart, it sprung a leak immediately. Water is leaking out of the pool at a rate of 3 times 2 to the t gallons per minute. How much water is in the pool after 4 minutes? I don't know. Okay, so write down what you think this is going to look like. I don't know. Started with 75, right? We want to know how much water's in there from after 4 minutes, so we're going to go from 0 to 4. Our rate is 3 times 2 to the t dt. So I want the final. I have the initial. Is this going to be plus or minus? Why? Okay. All right, go ahead and let's do this. When you don't even have to type it into the, let's just type it into the calculator part right here. So 75 plus, I'm going to do the integral. You're not going to sleep. You're doing this. Oh, okay. We're going to going from 0 to what? 4. And then we're going to type, just like it looks on there, 3, open parentheses, 2 to the x power dx. How do you go up in gallons? So, but listen, this is why I want y'all to listen and think about what we're reading. We have the initial, listen, we want the final, that's usually initial plus whatever the change is, right? Why is this one not working out that way? Well, because you can't grow gallons. So if we think about, well, you can grow gallons, but not when it's leaking out, right? But that's why we've got to be careful with what we're reading. Water is leaking out at this rate. So the amount of water is changing at a negative rate. Because it's using the word leaking, water is leaving. That's why either the minus needs to go here or it needs to go here. We can still put the plus here, have an initial plus the final, right, or plus the change rather, but it's really a negative rate because of the word leaking. Does that make sense to you? And you can catch yourself if you think about reasonableness of your answer, right? Like, wait, this makes no sense. I should have less. So that was a very good catch on that. All right, look at B. Write but do not solve. So really what you should get in the end is 10.079, yeah. We're not going to, you can't have negative gallons. You can't have negative gallons. I'm sorry, that doesn't work that way. Yeah, 10.079. All right, now what you think about this? Write but do not solve An equation with variable w that involves one or more integrals that can be solved to find when the time w when the pool is completely empty. When is the pool going to be completely empty? Yes. When is there going to be no water in the pool? What has to happen for there to be no water in the pool? 0 equals what? You're right. 0 water would have to equal the initial, well, depending on where you put it, you can put the minus here or here. But it's once this, so all this water's leaked out and we have 10 gallons left, right? I want to know when I have 0 left. I'll have 0, so if this is my 0 here, it's still going to be 75 plus the integral of this negative 2 t dt, right? Starting at 0 and going to w, whatever that time is. Does that make sense? So you were right. The way I wrote it the first time is I wrote it as 75 equals this, because basically it's when your net change has to be 75, but it's the same thing as 0 equal to both of those things, okay? So we good? Make sense? Okay. This last one, I'm going to give you the answer to this one, because I want you to set it up and do it. We don't have really enough time for that, but you should get 53.315. And then all of the practice problem, well, not all of them, but most of them are multiple choice, but set them up anyway. But I want you to actually practice on these. Okay, I'll leave the key up here so y'all know where to find it.